Well, enough of that physical chemistry. Let's do some organic chemistry and talk about how we can synthesize amines. And as has increasingly been the case as we introduce more and more functional groups, we're going to start to see familiar reactions and familiar species. So one way, for example, we can synthesize amines is starting off with halogenoalkanes. Now I'm going to start off with a negative comment. In your A-level specs, you are told that when you take an alkyl halide and you react it with excess ammonia dissolved up in ethanol, then you will have a substitution reaction in which we replace the halogen with NH2. That's not a good reaction. Very few card-carrying organic chemists are going to make an amine starting off with a halogenoalkane and just reacting up with ammonia. Okay, because this product here, right, the amine itself, that nitrogen's got a lone pair on it. That makes it a nucleophile. And so what can happen is you start getting a mixture of products as some of your products, when you make them, go back and start attacking other molecules of the halogenoalkane. Okay, the nitrogen with its lone pair is not the only nucleophile there. Okay, so you make a mixture of products. Now you can make amines quite nicely from halogenoalkanes using a couple of reactions that we've seen to different extents. First of all, we talked way back about reacting halogenoalkanes. It's one of the possible substitutions with N3, with this azide, to make an alkyl azide. Or we can react to halogenoalkane with cyanide to make a nitrile, and of course we saw that in a previous module. So you can actually introduce a carbon-nitrogen bond into an organic molecule by either reacting with N3, so you get straight off the R bonded to the nitrogen there, or bringing in the cyanide, which of course already has a carbon-nitrogen bond. Now, once you've made these, you can reduce them. When you reduce the azide molecule, it goes straight to the amine. When you reduce the nitrile, it goes again to the amine. But look at the differences in these structures. It's going to the nitrile gives you an additional carbon. Okay, so if you want to make an amine from a halogenoalkane, don't react it with ammonia. React it either with sodium azide and then reduce it, and that just turns the R group that you have into the amine, or react it up with sodium cyanide and you get the nitrile, and once you've got the nitrile you can reduce it to again make a primary amine with an extra carbon in there. Need to know this reaction for your A level, but not when you get into the organic lab. Now, I've talked about just reduction, just blithely mentioning reduction, where you've seen reducing agents before. One of the nice reducing agents is lithal, lithium aluminium hydride. We saw this when we were, first of all, talking about reducing carboxylic acids, because they reduce carboxylic acids with lithal. An alternative that we saw back then was instead of lithium sodium, instead of aluminium boron, so sodium borohydride, which you could work with in water, and you could reduce aldehydes, but you couldn't reduce acids with it. If you want to do a stronger reduction, which is what we're doing here, you have to use lithal. Can't have any water near it, so you have it in ether, and then once you've actually done the reaction, you follow it up with water to quench the whole reaction and get your products. So we can, if we want to, use lithal to reduce either our azide compound or our nitrile, or we can use another reducing agent that you've seen before. And of course, what is reduction but putting in more hydrogen atoms here? So indeed, if we take either of these and we react them up with hydrogen using a platinum catalyst, and of course you saw this way back talking about turning alkenes to alkanes, we can do that reduction here. So a couple of reducing agents we can use to start off with halogenoalkanes, go through the nitrile or the azide compound, reduction to the amines. We can also reduce nitro groups, and as we'll discuss in a minute, this becomes extremely important for some organic synthesis, organic synthetic chemistry. So take a nitro group, in this case nitrobenzene, reduce it, and you turn it into the aniline. And remember, aniline is featured already extensively in our discussion. It's going to feature even more in later movies in this particular module. Again, what do you use for the reduction? Well, you can use the hydrogen with the catalyst, or you can use, if you're intent on using metals, you can use iron or zinc, powdered iron or powdered zinc in concentrated hydrochloric acid, and then you just basicify it or neutralize it with sodium hydroxide. So we can make amines starting off with some substances we've seen before, halogenoalkanes or nitrated benzene rings, reducing it with these various different reducing agents.